Geometric mean. So this is from section 8.1 of our book. And it's geometric mean. That code belonged to my friend who actually made these notes. Okay, so if you recall, we have talked about proportions. So in our proportions, like one set up like this, these numbers right here, the A and D, are the extremes. And these numbers here are the means. Okay, so geometric mean is when that B and C, when they're the same number, okay? When they are matching. So for example, like A over B equals B over D. So the B is in both places. So that B is the geometric mean between A and D. So when we cross multiply, we get A times D equals B squared. And then take the square root of both sides to solve for B. Okay, so this is the formula that you would use. B is the geometric mean. And between A and D. Okay, so you take the product and then the square root. So let's see, square root of product of two numbers. All right, so this is the formula where B is your geometric mean between A and D, the other two numbers. But I like to just set up the proportion and cross multiply, because sometimes we give you the geometric mean and one of the numbers, and you have to figure out what the other number would be. And so it's easier to do it like this. So recall, that's where the word mean comes from, the geometric means, okay, from the means of the proportion. All right, so let's look at these notes. The geometric mean between two numbers, A and B, can be found by setting it up where A and B are your extremes and G is in the same place in both locations for the means, or any letter. And then solved by cross multiplication. So for example, find the geometric mean between 5 and 45. So I'm going to set up a proportion and put 5 and 45 in the extremes, and then I'm looking for the geometric mean. I'll call that G, here and here. So then we're just going to cross multiply. So I get G squared equals 5 times 45, or G squared equals 225. All right, so then we're going to take the square root of both sides of that equation so we can solve for the G. And so G is equal to the square root of 225, and that's 15. So 15 is the geometric mean between 5 and 45. All right, let's look at this other example. 16 is the geometric mean between 8 and which number? So this is what I was talking about. I'm giving you the geometric mean, and you have to find the other number. So we set up our proportion and write 16 in the means places, and we have it between 8 and a number. So we have to solve for that number. So here we're going to have 8x equals 16 squared is 256. Okay, and then we're going to divide both sides by by 8, and get x equals 32. So 16 is the geometric mean between 8 and 32. So that is what geometric mean is. All right, so with the geometric mean, we have two other theorems that we're going to talk about, and it's the right triangle altitude theorem and the right triangle leg theorem. So let's look at the first one. The altitude from the right angle in a right triangle is the geometric mean of the divided parts of the hypotenuse. So the length of the altitude that's drawn from a right triangle to the hypotenuse, it divides that segment into two parts. Okay, the whole hypotenuse is now divided into two parts. So the length of the altitude is the geometric mean between those two parts. So I'm going to call this one part 1. And this one part 2. Okay, and the altitude is, all right, so we have the altitude is the geometric mean between part 1 and part 2. So this is our formula. So let's plug in the numbers. We have z is the altitude. It is the geometric mean between 8 and 25. So we have z squared equals 8 times 25. That's z squared equals 200. So we take the square root of both sides of our equation to solve for the z. And z equals, well, it's not a perfect square, so it's approximately 14.142. So going to the calculator, 200 square root 14.1421, okay? But I want you guys to simplify the radical. Do you remember how to do that? Let's see, we have 200, and we want to factor it to its prime factors, and then for every pair of prime factors, we have a perfect square. So we can pull that out and leave what's left underneath. So let's start factoring. I know 200 comes from 2 and 100. That's a prime. This is 2 and 50. 5 and 10. 2 and 5. Okay, so that's all prime factors. Then I take all the pairs. So I have 1, 2, 3 2s. And two pairs of, or 2 5s. So I have a pair of 2s, that brings, the square root of that is 2. I have a pair of 5s, and the square root of that is 5. And then we'll leave our 2 underneath the radical, so we have 10 square root of 2. Okay, so I'd like for you to do both. Simplify the radical and find the decimal. The reason I'd like you to find the decimal is I'd like you to know about the size. Like, what is we may not really know what 10 square root of 2 is. Is it somewhere between 8 and 25? It's hard to tell. But I do know that 14 is between 8 and 25, so it's a reasonable answer. All right, so the altitude is the geometric mean between the two parts of the hypotenuse. Okay, so now the next theorem is the right triangle leg theorem. So on this one, the leg of a right triangle is the geometric mean between the hypotenuse and the adjacent part of the hypotenuse when it is intersected by the altitude drawn from the right angle. All right, so if that altitude is drawn there from the right angle, this leg is the geometric mean between the whole hypotenuse and the little part of the hypotenuse adjacent to it. Okay, so the leg is the geometric mean between part 1, or this one is part 1, and the whole hypotenuse. Okay, so we have leg, and then we have hypotenuse, and adjacent part. Okay, so in this case, x is the geometric mean between 8, oops, that's not the hypotenuse, 8, and the hypotenuse, which is adding 25 plus 8, so that's 33. So the length of that one leg is the geometric mean between 8 and 33. So we have x squared equals 33 times 8. So x squared equals 33 times 8. 264. All right, so we'll take the square root of that, and we get x equals the square root of 264, which is not a real perfect square. We know it is approximately 16.248. But let's simplify our radical. So 264 is an even number. I can't, off the top of my head, I'm not thinking of any factors of it other than it's even. So let's do 2. So I'll divide 264 by 2, and I get 132. Do it again, divide by 2, it's still even, and get 66. Okay, and I know 66 goes into 6 and 11, which is a prime number, and then 6 goes into 2 and 3. So if I do the square root of 1, 2, 3 2's, and a 3 and an 11, take out one of the 2's, and all the rest of them I have to multiply together. 6 times 11 is 66. So it is equal to 2 square root of 66. Okay. So the leg is the geometric mean between the part right next to it and the whole hypotenuse.